My name is Dana Golden. Today we're going to talk about how electricity generators bid into the market and how they choose how to provide services. So the optimal objective of optimal bidding is to maximize expected profits by strategically setting bid prices, figure out what your marginal cost is, and figure out what you think the market's price is, and set bids to maximize your revenues and your profits based on your marginal cost curve. You want to account for uncertainties in demand, competitive behavior, and market prices. You also want to, ideally, if you're a renewable generation, account for potential uncertainties in your ability to supply. You want to balance risk from potential penalties from imbalances with rewards from market-cleared bids. So if we're doing the mathematical formulation of this, we want to define our variables. Qi is a quantity of electricity bid by generator I. Pi is the bid price per unit of electricity by generator I. D is the forecasted demand of the market. So the objective is to maximize profit. Pi I equals Pi times Qi minus Ci, which is the cost function of generating Qi units of electricity. So you're subject to the constraints that supply has to meet demand. This is an equilibrium constraint, which comes out of the market. So this is not based on the individual generator, but the generator has to be aware of it because prices will be such that quantity equals demand. You have capacity constraints. You can't produce negative unless you're a battery, in which case you can take energy from the grid, and then you always have to produce less than your total capacity. And then you shouldn't bid negative. Actually, you can bid negative, particularly if you're a battery. And a lot of renewable generators will bid negative because they face a cost of curtailment. But often you will see most fossil generators will never bid negative. And then the market clearing price is the marginal cost of the last generator selected to be dispatched. So incorporating risk and uncertainty, you can model uncertainty with a probabilistic distribution of demand. And then you can use expected profit based on the expected price and the expected quantities that you want to supply. And you can model the risk inherent in the system because you have uncertain price, you have uncertain quantity, and you have uncertain generation if you're a renewable resource. So analytical, you solve for P and Q that maximize profit under constraints. You try and set bids so that they're greater than your cost, but also so that if you are the last resource, they encourage greater LMP than your marginal cost, so you can get back some of your operations and maintenance costs, but also so that you can get back some of your fixed costs. And then use Monte Carlo methods to simulate different demand and competitive scenarios. Normally use a linear or stochastic optimization. Linear program is stochastic optimization. So here is a graph, power quantity and price. Power quantity is on the x-axis in megawatts. Price is on the y-axis. You have the demand curve, which really often in electricity is treated as vertical because it's inelastic, as we talked about before. And then you have a supply curve that is based on a bunch of marginal costs. And then finally, you have the last marginal cost, the last generator. Right there is the price, and that's going to be the price of electricity. So mathematical formulation of the ISO's problem. The ISO is looking at all the bids to solve this. And so the goal is to minimize the total cost of generation by dispatching the correct set of generators to minimize cost. So you want to minimize the correct set of generators I for the correct set of quantities based on power output from each generator and based on the cost of each generator. You want to balance supply and demand. You have a sum of power outputs is equal to demand. And then you have some generation capacity limits where each generator has a minimum power output and a maximum power output. Most generators incorporate this through their bidding function. Most of them provide a schedule of quantities and prices that incorporate the fact that they have a minimum and maximum output, and they have a cost of ramping. And then you have transmission constraints. For any particular line, the power flow on the transmission line is less than the maximum capacity of the line for all lines. And so the ISO problem is to then set the locational marginal price, choose a price, which is the shadow price of demand, and locational marginal price at each location, such that the locational marginal price is equal to the marginal cost generation at that location. So effectively allocate generation of minimized costs while ensuring system reliability. So challenge of the real-time and day-ahead market. The day-ahead market must settle before generation and demand are known. Generators must decide bids without knowing state in real time. So you decide bids and you don't know what the other people are bidding. You just have to trust that you're bidding at least your cost, maybe above if you think you might have market power. And then you have to decide how to bid without knowing what's going to happen. If you're renewable, how much you're even going to generate, and often how much you're going to have in demand. Getting it wrong can be costly. You might underbid into the market. You might bid too highly because you thought you had market power, and then you won't get any revenue. So how to solve this? You look at the supply stack, you figure out the supply stack, and you basically figure out where you stand on the supply stack and use that to create your bid. Normally, the best way to bid is to bid exactly at your marginal cost, because you should not generally assume you have market power. So renewables often marginal cost is 0, so normally they bid a little bit above their marginal cost in most cases. But normally they're also not the last resources, so they normally let someone else set the price, and they so they want to bid above their marginal cost. In the case that you do set the price, they're still making a little bit of profit, but they let someone else set the price and take the price of the marginal resource. Here's an old version of the PJM supply stack. Now natural gas is pushed a lot forward. As it used to have that you had renewables, then nuclear, and then coal, and then natural gas. Now you have a lot of coal here. And then oil and wood-burning generators rarely get dispatched. And so next time we'll talk about renewable bidding. Hope you have a great day. Thank you.